In this video, we are going to understand this linear algebra topic, like how to find out a distance of a point from a plane. Okay, so let's consider that I have a plane over here and this is specified by pi. Okay, now with respect to this, and you know that if this particular plane passes through the origin, we can definitely use a equation which is like W transpose x is equal to 0. We just discussed this in our previous video, right? Now, when W transpose x is equal to 0, what is W over here? We can definitely say W is a vector that is perpendicular to this x-axis, that is this plane, okay, or this plane specifically, okay. Now, let's say if I have a point, okay, and let's say this point is specifically specified by x, and this has some coordinates like x1, x2, x3, like this up to xn. Let's consider that this is an n-dimensional plane, okay. Now, how do I try to find out the distance between this particular point to this particular plane? And this is super important because in some of the algorithms like logistic regression and SVM, we are going to use this, because in logistic regression, we usually solve a classification problem. Classification problem basically means I have some coordinates, like some classes over here, some classes over here. And our main aim is to basically find out a best fit line such that it should be able to split these 2 points very easily, so that if suppose my new point come over here, it should be able to categorize in this particular group. Okay, that we'll probably be seeing as we go ahead. Now our main thing is that how do I find out this distance of this point S with respect to this particular plane? And let's say there is one more point which is over here, and let's say this is mentioned as S dash, and this is mentioned as x2, x3 till xn, considering n dimension plane. So I also want to find out the distance between this particular point to this particular plane. And here you should note that W is perpendicular to this plane in this direction. Okay. So when I say perpendicular, it is 90 degree, right? Now usually in this particular scenario, if I really want to find out the distance, again, I'm not going to prove you the formula that is basically used to calculate the distance. But in short, I'll try to write down the formula. So this D distance is basically calculated by W transpose S. S is basically my point, this point, that is x1, x2, xn, like this up till xn, divided by the magnitude of W. Okay. So this is the equation that is basically used. Again, proof, you can definitely refer some of the topics related to this even in Google. You'll be able to find out the proof. Like if I really want to compute the distance, considering my W vector and the S vector, which is again perpendicular to this particular plane, and W is in this direction, it is basically given by this particular equation. And obviously from this, you know that if I try to calculate W transpose X, this is nothing but magnitude of W, magnitude of X multiplied by cos theta. So in short, if I really want to find out the distance of this point from the plane, I may also consider this W and X, right? So in short, I'm going to use this, right? And whatever angle is basically getting formed, and obviously this angle that you will be seeing that is getting formed is less than 90. So if it is less than 90, that basically means I'm going to get a value between 0 to 1. So it is always going to be positive. So if I do this entire computation, this is going to be positive. You can see this angle between this W and X vector, it is always less than 90, right? In this particular case. So if I'm trying to calculate the distance with respect to this, right, I'm also always going to get a positive number. So that basically indicates that suppose if I have any other points, and if I try to calculate the distance between from this particular point to this particular plane, on top of this plane, I'm always going to get a positive number. Okay, that is the indication that we can come up with. Now similarly, what will happen about this D dash? That is, below this plane, there is another point which is called as S dash, and we really need to find out what is the distance between this particular point to this. And you know that W vector is in the opposite direction. So in this particular case, my D will be W transpose S dash divided by W, right? Magnitude of W. And this in turn, if I just take W transpose S dash, it is nothing but magnitude of W multiplied by magnitude of S dash cos theta. Now you know that over here in the above case, my theta was between 0 and 90 degree, right? It will always be less than 90 degree because it is above this particular coordinate. But what about in this particular case? If I try to contact this W and if I try to connect this W and S dash, here the type of angle that we are going to get is always greater than 90. And whenever we have any angle that is greater than 90 and less than 270 or less than 180, you know that we are going to, so here we are going to get greater than 90 and less than, or I can just consider greater than 90, and it can also be less than 270. Here all the time with respect to any angle that I get greater than 90, here I am going to get a negative number, right? So this indicates that any point that are below this hyperplane, right? And if we try to calculate the distance, this is always going to be negative. Okay, super important point. Any point that are above this plane, and if we are trying to calculate the distance by using this particular formula, which is basically my distance formula, in short, all the time, and why this is happening, because above this plane my cos theta value will be between 0 to 90. Here it will be always greater than 90. Okay, so in this particular case, always this is going to be positive. The distance above this particular plane is going to be positive, and similarly distance below this particular plane is going to be negative. This is a super important point in order to calculate the distance of a point from a plane. And two important points, that yes, anything above this particular plane which is in the same direction as the W vector, you'll be seeing that all will be having a positive value or positive distance. This will basically be having a negative distance. Why we are saying negative distance is just that it's not like negative distance literally means something like negative distance, but instead it is just saying that it is in the opposite side of the plane. Okay, so this is how we basically indicate, and this same concepts we are going to use it in support vector machine. So I hope you got this particular idea with respect to the equation of a straight line, distance of a point from a plane. Equation of a straight line was already covered in our previous video. So yes, I'll see you all in the next video. Thank you.